Hi everyone, it's Mrs. Parr back with you again. So as we always do, our first job is to go over the practice activity from the last session. You looked at consecutive numbers, and where we have consecutive numbers in a subtraction, the difference is 1. Do you remember that? Well done. Okay, so you were using that to help you sort out these expressions into a table where they were either had a difference of 1 or not a difference of 1. Shall we see how you got on? Okay, so the first one we're looking at here is 4 minus 3. 4 minus 3. What do you notice about those two numbers, 4 and 3? They're consecutive, so they have a difference of 1. Well done. So what about the next one? 8 take away 7. Are they consecutive numbers? Yes, they are, aren't they? So they have a difference of 1. Now, I wonder if you got caught out on this next one. 1 take away 0. Are 1 and 0 consecutive numbers? Yes, well done. They are. They're next to each other on the number line, aren't they? Well done. So they do have a difference of 1. 1 take away 0 is equal to 1. Good. Let's have a look at the next one then. 4 subtract 1. Well, there's a 1 in there, isn't there? But are they consecutive numbers? No. So do they have a difference of 1? No, they don't. Well done, everyone. 6 take away 4. 6 minus 4. Not a difference of 1, is it? Because they're not consecutive numbers. Well done. Now, 9 subtract 7. Not consecutive numbers. Not a difference of 1. Well done. Now, here's some really big numbers. But did you spot the pattern here as well? 39 minus 38. What do you think? Are they consecutive numbers? I wonder how you knew. They are, aren't they? If we've got 39 and 38, they must be consecutive numbers because 9 and 8 are consecutive numbers. Well done. So they do have a difference of 1. I bet you did all sorts of brilliant examples for yourself. And as long as the two numbers were consecutive, they will have a difference of 1. Well done. So we're going to start today's lesson by having a look at our number block friends. Can you wave hello to your number block friends? There they all are, all multicoloured. We're going to look at the shape of them first. Do you notice anything about the shape of our number block friends? Do some of them have a similar shape and other ones have a similar shape? Have a look and see. I wonder what you spotted with our number blocks. Is it easier to also look at them with the numicon underneath? We can see the shapes even more clearly with the numbers in the numicon and on our number line. So what have you spotted about the shapes? Some of the shapes have a smooth, even, you might say, top to them, don't they? Can you see that 2, 4, 6, 8 and 10 all have a nice, even, smooth top to them. There are no sticky up bits. Okay, so what does that mean? Let's have a think about what that might mean then. I bet you're all shouting at the screen. They are all even numbers. Good job. They are our even numbers. So what do you think then about the shape where they're not smooth at the top? That one is, but it's all by itself. It doesn't have a partner. And then there's poor one sticking up on his own and nothing next to him there. Poor number 3. And then number 5, we've got a little gap there, haven't we? His head sticks up all by himself. And the same with number 7 and the same with number 9. What does that mean if they've got an odd little bit sticking up? Well done. They are our odd numbers. So now we're going to do some counting, but we're going to do it in 2 different ways. First of all, we are going to say all the numbers in our number line, but we're going to whisper the odd ones and say the even ones much more clearly. Can you see which ones you can see more clearly on our number line? Good, you can see the even ones more clearly, can't you? Are you ready to count from 0? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well done. But this time we're not going to say our odd numbers at all. We're actually going to skip count, aren't we? We're going to skip count in 2s starting at 0. Ready? 0, 2, 4, 6, 8, 10. So we've said all our even numbers by skip counting in 2s. Brilliant, well done. Now we're going to do exactly the same thing. We're going to count through, but we're going to whisper the even numbers, the ones that are faded out this time. So let's start on 1. Are you ready? We're going to say the odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now let's go skip counting again, but starting on 1 this time. Can you do that? It's a little bit harder. Are you ready? 1, 3, 5, 7, 9. Shall we go backwards as well? Let's really challenge ourselves. Let's go backwards. Ready? Starting at 9. 9, 7, 5, 3, 1. Well done. So this time we're going to make it a little bit harder. All our numbers are there, but we are going to skip count starting on 0, which means we're going to skip count in 2s, which means we're going to say all the even numbers. Are you ready? 0, 2, 4, 6, 8, 10. Let's start at 10 and go back. 10, 8, 6, 4, 2, 0. Well done. I hope you got on okay with that. Now, I think this is a little bit harder because we don't do this as often. We're going to skip count in 2s, but starting on 1. So we'll end up saying all the odd numbers. Good. Are you ready? 1, 3, 5, 7, 9. Should we go back? 9, 7, 5, 3, 1. Good job, everyone. Now we've got a little bit of a missing number problem. We've got the number 7 here in the middle. And over here in this missing number box, we need to put the next odd number. Okay, there's an arrow going that way. So it's not the next number, it's the next odd number. And over here, we need the previous odd number. So again, not the number before, but the previous odd number. So how are we going to work this out? What do you think? Here we've got 7. So the next number would be 8. Is that odd? It isn't, is it? So our next number will be 9. You're absolutely right. Well done. So in here, I'm going to write the number 9. Well done. Okay, what about then this other number? We need to look at what our previous odd number is. So here we've got 7. What number comes before 7? Think about your number line. 6. But that's not odd, is it? It's even. So now we need 6. 5. Well done. Let's put it in then. Good job, everyone. Shall we just use our number line to check? Here's our number 7, and we said, didn't we, that 8 there, but that's an even number because it's smooth at the top, whereas 9 has a bit sticking out, so it must be an odd number. So there we go, well done. And the other way, there's the number 5, our previous odd number. This time we're looking for the next even number. We start with 4. Is that an even number? Yes, it is. Well done. Can you picture in your head the shape of our number 4? Is usually a square, isn't it? Nice and even at the top. Good. Okay, so we're going to look our next even number. Is it the number next to 4 on the number line? No, well done. We have to jump over the number 5 to get to the number 6. Well done. Okay, and then the one before, the one that comes before 4. Not just the number before 4, because that is 3, but the number before that is 2. Well done. Let's double check again. Here is our number 4. Our next even number jumps past the 5 is our number 6, and our previous even number jumps past the 3 and is the number 2. So what is it that we're actually doing when we're skip counting in 2 or when we're saying all the even numbers? What calculation are we doing? Should we have a look? Okay, so when we go from 0 to 2, what's happening? 2 to 4, 4 to 6, to 8, to 10. What are we doing? What are all those jumps? What calculation are we doing? Well done, everyone. We're adding 2 each time, aren't we? That's what skip counting in 2s does. We're adding 2 to the number we landed on. Well done. So now we're going to concentrate on that idea of adding 2. Okay, so we're going to start with 0. There's nothing in my tens frame, is there? And we're going to add 2 to that number. Are you ready to see what happens? 0, add 2. Oh, we've got the whole row on the bottom of our tens frame filled up. So 0 add 2 is equal to 2. Good, well done. So if we start with 2 and add 2 to it, we get 4. You're absolutely right. 4 is our next even number. Okay, do you think that will always work? If we have an even number and we add a 2 to it, do you think it'll take us to our next even number? Shall we try it out? Let's have a go. So this time we start with 4 and we add 2. Oh, look, what have we got? It's like the counters just slotted in underneath, wasn't it? They've just gone in underneath and pushed the other ones up. It's still even at the top, isn't it? There are no ones popping up on their own. So we've got 6, which is our next even number. Does look like it works, doesn't it? Okay, do you think you can think of a rule? We're going to start with this 6 this time. Are you ready? What do you think is going to happen? Can you predict what the answer is going to be? So we start with 6 and we add 2. Is that what you thought would happen? We have got 8. 6 add 2 is equal to 8. We're on our next even number. I bet you all know what's coming next. Ready to start with 8? 8 add 2 is equal to 10. You know that one, don't you? Because it's one of your special number bonds to 10. And we can see that our tens frame is full. 8, which is an even number, add 2 is equal to 10, which is our next even number. So if this always happens, we can say it's a generalisation. We can know that it will always happen. Adding 2 to an even number gives the next even number. It's going to be important for us to remember that because it makes adding 2 really easy. So then, what if we skip count starting on 1 like we did earlier? Shall we see what happens? So I've got the same skip counting, 1, 3, 5, 7, 9. I've jumped in 2 still. So what calculation do you think I'm doing? Some of you have got it, haven't you? We're just adding 2 again. We just started on the number 1 instead of 0. Okay, so we're jumping all the odd numbers. So I just want you to have a look now at what's happening here. We've just got one counter all by itself in our tens frame, and we're going to add 2 to this. Can you picture what might be about to happen? Have a think. 2 counters have come to join it. So we had 1 and we've added 2 and we now have 3 counters, our next odd number. Okay, so we're starting with 3 this time. Let's see what's the same and what's the difference to when we were doing it with the even numbers. Are you ready? 3 add 2. Okay, so they just slotted in again, didn't they? So what's the same? 2 more come and join the tens frame and push the other ones up. But what's different? It's not even on the top, is it? It stays odd because it just pushes them all up, and we've still got this gap, so we've still got an odd number. 3 plus 2 is equal to 5, our next odd number. Well done, everyone. So now we're starting with 5, and we're going to add 2. Can you predict what it's going to be? 5 add 2 is equal to 7. Well done, our next odd number. I bet you all know what's coming next. Are you ready? Last one. We start with 7 and we add 2. 7, an odd number, add 2 is equal to 9, our next odd number. I think this one works as well. So can we write another generalisation? Adding 2 to an odd number gives the next odd number. So here we have our 2 generalisations side by side, and there are some bits that are the same and some bits that are different. So I'm going to read you the first one at the top. Adding 2 to an odd number gives the next odd number. Then the second one. Adding 2 to an even number gives the next even number. Why don't you pause here and just have a think about what is the same and what is different? Did you come back? Well done. So both times, in both generalisations, we were adding 2, weren't we? But on one we started on an odd number and it gives us the next odd number. And in the other generalisation we are still adding 2, but we start on an even number and it gives us the next even number. There's just one more thing I wanted to tell you about adding 2, and it's really important, but you already know it because we've already come across this idea and this generalisation. Are you ready? So at the top here, I've got 7, add 2. We know it's going to be 9, don't we? Because it's an odd number. Add 2 gives us the next odd number. But do you remember what we said before? Have a look at this generalisation. When you change the order of the addends, the sum remains the same. So what's going to be down here under my box? What do you think I've done? If we change the order of the addends, the sum remains the same. Tell me. Good. If 7 add 2 is 9, then 2 add 7 is equal to 9. It doesn't matter where the 2 is. If there's a 2 added on in your equation, then it's going to be the next odd number. I think you know what's coming now. I think you can already predict it. So here we've got the even version, haven't we? 6 add 2 is equal to 8. And when you change the order of the addends, the sum remains the same. So what's under here? 2 add 6 is equal to 8. And all we have to do is in our head, we just swap it around, don't we? Because it's easier to say an even number add 2 is the next even number. So it's just easier to look at it as if 6 is at the front. So this is what we're going to have a go at now. Can you see all these sums down the side? We are going to have a look first of all at these ones here, these equations, okay? And you're going to have to fill in the missing number in the equation. So have a look first of all at that first number, and then we are adding 2 to it, and we're going to put the number in the box. Are you ready? Because what I would like to do is I'm going to say the first number, then you're going to add 2 to it in your head. You're not going to count on, you're going to jump to the next odd number, aren't you? Because I hope you've spotted that all these ones at the beginning are odd. Are you ready? So I will say 1. You add 2 to it in your head. Do that jump. Add 2 is equal to 3. Well done. You ready? I'm going to say the next one. 3, you add 2, is equal to 5. Good job. Well done. Right, next one. 5 is equal to 7, our next odd number. Oh, this time we're starting with 7. 7 equal to 9. And the last one on this list, we're starting with 9. 9 is equal to 11. Well done. We hadn't gone up that high, had we? Good job. What did you notice? Did you notice that these were all the odd numbers? We added 2 and it made the next odd number. Then what did we start with? We started with that odd number, didn't we? Good job, everyone. Right, I want you to have a pause and I want you to have a go at this second list here, and then we will go through them again. Don't forget, when we're adding 2 to an even number, it gives us the next even number. Have a go. Ready, everyone? Let's do them together then. 0 add 2 is equal to 2. It's the next even number. 2 add 2 is equal to 4. Fantastic. 4, you add 2 is equal to 6. 6 add 2 is equal to 8. And 8 add 2 is equal to 10. Great job, everyone. Well done. So it's time for me to leave you with your practice activity for today. Okay, and just like the page before, you've got 2 lists of sums. Okay, 2 lists of equations with a number missing. The sum is missing. So these are the 3 things you're going to have to remember. Adding 2 to an odd number gives you an odd number. Adding 2 to an even number gives you the next even number. But this is the one that I need you to remember because we haven't done this yet. This is the extra bit of challenge. Are you ready? When you change the order of the addends, the sum remains the same. You're going to need all 3 of those rules to help you to solve these problems without having to count on your fingers. You know the rules, so it's time to use them. Okay, have fun everyone. Bye.